The volumes of soda in quart soda bottles are normally distributed with a mean of 32.3 ounce and a standard deviation of 1.2 ounce. What is the probability that the volume of soda in a randomly selected bottle will be greater than 31.5 ounce? Now here, the important word here is that it's normally distributed. Sometimes they would just say the distribution is shaped like a bell curve, okay? So in such a case, and also you don't see any probability attached to a single item, right? So it's not binomial distribution. If it says normally distributed, it is the normal distribution. So that's kind of easy, okay? So if X is the volumes of soda in quart bottles, then this X follows the normal distribution with 32.3, 1.2, and this is just a symbol for normal distribution with the mu being, or the mean value being 32.3 and the standard deviation being 1.2. And it's a lot of times writing this out will help you to know how to use the formula. So try to make a habit of writing this down, okay? And then the question is about the probability of X being greater or equal to 31.5. Now, when you have a question about probability in normal distribution, you first want to translate this into the standard normal distribution by way of something called a z-score. So how do you calculate the z-score? You take these values in the p and subtract the mean value, which is 32.3, and divide it by the standard deviation. In our case, it's negative 0.6667. And then with this value, we can rewrite the question as what is the probability that the z of the standard normal distribution is greater or equal to negative 0.6667. Now, because you're trying to get a probability in a normal distribution, it's often suggested that you draw or shade the region that you're trying to calculate the area of. So this is the standard normal distribution graph, and the area under the curve is related to, or the area under the curve gives you the probability. And what we are trying to do here is, here's something like, let's say this is about negative 0.667. And here, so this is negative 0.667. And we're trying to find the area on the right side because z is greater or equal to. So as you can see, the place where z is on the right side of negative 0.6667 is this shaded area, and we're trying to find the area under this curve. The problem is that whether you're using a chart or a calculator to get this area, the most convenient functions give you the area under this curve from negative infinity up till negative 0.6667, or any given value. So what you want to do is you want to represent the target area as the entire thing minus this side. See, if you take this much and chop off this much away, then you're only going to get left with this much, right? So that's why this picture makes sense. And another thing that you have to know is that the area under the normal distribution is always 1. And therefore, what happens is that you have this formula, probability that z is greater or equal to negative 0.6667 is equal to 1, which is this area, minus this area, which is the probability where z is on the left side of negative 0.6667, okay? So we're going to use this formula, and that means we just have to calculate this. So how do we calculate this? Well, you can use a calculator using a TI-84. You can click second vars and choose normal CDF. CDF means cumulative distribution function, and it for normal distribution you want to find the cumulative, or the area, the sum of all the area from negative infinity to that number. That's why you have to use CDF, not the PDF. Okay. So for the binomial, you would use PDF. Some call it PMF. But for normal, you use CDF. Let me go to the calculator. In our case, you see here CDF. You click that one. And negative 1e99, that's like negative 1 times 10 to the 99th power. That's practically negative infinity for this calculator. So this is like from negative infinity up until the upper would be 0. Actually minus, I forgot. So negative 0.6667, and then enter. Because this is the standard normal distribution, the average is 0 and the standard deviation is 1, so you don't change that at all. So you only need to put this in there, okay? And it's important to be consistent. Don't change these other ones, because if you start doing that, you're going to get confused. You just want to stick to only changing the upper, okay? So you do this and enter. And if you're using a TI-83, then unfortunately you have to remember all the sequences, always -1. And by the way, this E, if you want to put that in your calculator, you have to use EE, which is this one, second of this comma. It gives you this EE, and that gives you this E symbol, and then put 99, comma, negative 0.6667 for the value, the bound, upper bound, and then you put 0 and 1 for the standard normal distribution. So if you do this, you're going to get this 0.2525. So as said earlier, you have to subtract from 1, and the answer is 74.75. Now, some teachers ask you to use a chart, like in that case, you may be given a chart like this one, and if you go to negative 0.6 and 0.7, the problem with the chart is that you can't do negative 0.667 or 6667. If you round it to the nearest, it's like negative 0.67, right? And if you look at the value, this is like 0.2514, not 0.2525. But that's still a good approximation. So you use this value, and you would get some value that way. If you subtract 1 minus 0.2514, you're going to get 7486, not 7475. So that will be another answer if you're not allowed to use a calculator to do it.